Good morning. Greetings to the audience. My name is Theodore Karol Gabriel, and I'm from University of Indonesia. And yeah, we flew all the way from Indonesia to here just for these presentations. And I'm not alone. I'm with my partner.
Hello, my name is Nobel Judah Perwira.
And we are here to present our research about nickel slag as a partial substitutions of fine aggregate in concrete.
Okay, before we start, I would like to acknowledge our supervisors. These are Dr. Josia Irwan, Dr. Jessica, Dr. Nur Aziz Handika, and also Dr. Sotya Astutingningsih. Okay, before we start, I would like to talk about the table of contents of today's presentations. We will talk about the background of this research, or why we even talk about the use of ferronickel to replace the M-sand in our concrete. The second one is about the materials and the experimental program, or to put it simply, our research methodology. Next one, we will talk about the results and discussion, the data that we got from the research, and lastly, we will talk about the conclusion of this research.
So the first is the background. The first point of the background is I would like to introduce to you what is ferronickel slag anyway. So the ferronickel slag is basically a byproduct of ferronickel's productions, and it mainly used worldwide as production of stainless steel, and it will has a higher development in electrovehicle battery worldwide. And the second reasons and the second background why we use these materials, because this is a byproduct materials, and as we know, that the concrete is not an environmentally friendly materials. So we hope by using this byproduct as aggregate substitutions, it can reduce the carbon emissions, while at the same time we gain more advantage in compressive strength. And the third is, we are going to show you that every ton ferronickel produced, it also produced 12 until 14 tons of ferronickel slag as a byproduct, which means from the nickel ore, more than 80% will become a ferronickel slag, while the rest of 20% will become the main product. So yeah, most of it will become the byproduct. And in Indonesia, in our country, we produce 13 million metric tons of ferronickel slag each year, yet it is not being utilized really well until today.
Okay, the next one, I will talk about the analyzing using digital image correlation. So in this research, we will use a method called digital image correlation, or DIC for short. This analysis will help us to evaluate the local displacement of the specimen, and we use this data to get to analyze the strain and the stresses of the specimen later. And last point, we will talk about the FNS, or ferronickel slag in mortar and concrete. So why we choose FNS? Well, my partner has already explained to you guys some of the reasons, and one of the last reasons is there are some past studies that shows that using FNS in concrete, in mortar, it might actually increase the workability and also the compressive strength of the concrete. And in this research, we will talk more about the compressive strength. Next up is the research methodology, and first I will talk about the mixed design proportions. In this research, we actually casted 12 specimens. We have 3 types of variations, 4 specimens for each types of variations. The first variation has a 0% FNS, 0% FNS replacement as the control. The second one has a 50%, and the last one has a 100%. The other variables are kept the same, so we just change the amount of FNS inside the specimen. Next one, for the specimen preparations, we casted 2 types of shapes. We have a 10 diameter centimeter by 20 cylinder, and also a 15 by 15 by 15 centimeter cube. The cylinder one will be used for the compressive test, and the cube one will be used for the DIC analysis later. And if you can see on the right side of the page, we actually spray paint one of the side of the cube with a white paint, and then we gently sprayed the white paint with a black paint. This will help us to do the DIC analysis later. And for the testing method, we use a destructive compressive test to evaluate the compressive strength of the concrete, and we use the digital image correlation to evaluate the deformation behavior of the concrete. And once again, on the right side, we can see the test setup for the DIC. It consists of a compressive load dial, the specimen, the lighting to help the camera take a better picture, and also the camera to take the picture.
And now to the main point of our presentations, the result. The result from the compressive strength, we can see from the graph that it has indeed increased the compressive strength of the concrete as we increase these partial substitutions, while the most optimum partial substitutions falls at 50% of replacements. At any old age, it has the highest compressive strength. And the next result is the density of the concrete we use. As we increase the partial substitutions, it also increases the density of the concretes, and it does just make sense because this ferronickel slag has a higher specific gravity than the manufacturer sense we use as the control variables.
Okay, the next one is about the Poisson ratio, and from this research we get that it shows that the FNS replacement actually decreases the Poisson ratio of the concrete, as generally a higher compressive strength of the concrete, the lower the Poisson ratio is. And from the graph of the compressive strength, we see that FNS replacement increases the compressive strength of the concrete, so it decreases the Poisson ratio. And for the load displacement relationship, okay, we have two figures right here. The first figure on the top right of the page, it shows that FNS replacement in the mortar and concrete actually give a higher resistance to displacement. And from the graph on the top right of the page, we can see that FNS 100 shows a higher resistance than FNS 0 and also FNS 50. Even though FNS 50 has a higher compressive strength, just like what my partner told you before. And on the bottom side, we can see that all variations seem to have a relatively consistent response at early loading stage. This means that FNS replacement doesn't really give much of an effect, or doesn't really give a significant effect on the early loading stage of the concrete.
Okay, jump to the conclusions. The first conclusions we get is the specimens with FNS as a product partial substitutions indeed has a higher compressive strength than the control, with the 50% replacement is the most optimum. And by that, we really hope that this research of us can be applicable at the futures. And the second conclusion is the density of the concrete increase as the ferronickel slag replacement increase. So it has to be our concern if we are going to make a model of an element of structural element, because it may affect the structural system as a whole structural systems.
For the third point of the conclusion is the specimen with FNS replacement has a lower Poisson ratio than the control or the 0 FNS1. Now this means that if you are going to, this means that the specimen that has FNS replacement has a more resistance to cracking and also to fracturing. And for the last point of the conclusion, the specimen with FNS substitution show less displacement under the same loading. This means that the specimen has more stiffness. Now this might be a good, we need to keep this in mind if we want to make a structural element or maybe a structural system that need a more stiff element in it. This might be helpful. And these are some of the reference that we use in this research. And before we end this presentation, we would like to say our gratitude to the sponsor that help us, that enable us to be here right now. I would like to say the name of the sponsors. I would like to thank you Pulau Intan, Bank Rakyat Indonesia, Integrated Design Engineer, Bina Rekayasa Anugrah, Simaka Konstruksi, Delta Ultracon, and also Seed Scholarship.
And as a closing statement, as Nobel has mentioned before, there's no way we will be here without them, because we need that a lot of money for the flights. And we also hope this research can bring bright to our nations. It can increase and improve our economic for our nations, for our country, Indonesia. And I hope this research can be more applicable in the futures. And thank you. That's all from us. Let me know if there is any questions.